Welcome guys. This video demonstrates the steps that are necessary to create a bridge model using SAP 2000 and within SAP 2000 the bridge menu. Okay, the bridge that has been shown to you will be remodeled for you people in this video, and please keep in mind that only the modeling of the superstructure will be done in this video, and in the next video I will perform the analysis for the vehicular load of the same bridge. Okay, the details of the bridge are that the bridge is a two-span pre-stressed concrete box girder bridge, and it has the following features. Abutments. The abutments are skewed or tilted by 15 degrees, okay, and are connected to the bottom of the box girder only. So you can see that the abutment is connected to the bottom of the box girder. Pre-stressed, the concrete box girder bridge is pre-stressed with 4 tendons, and the area is 5 square inches, and one tendon is in each girder with a jacking force of 1080 kips each. Okay, so you have to convert it into KSI, right? The bends, there is one interior bend with three 5 feet square columns, right? So you can see that there is only one bend, and for now I have merged these columns into a single one. Deck, the deck is a concrete box girder with a nominal depth of 5 feet, right? The depth of this deck is 5 feet. The deck has a parabolic variation in depth from 5 feet at the abutments to a maximum of 10 feet at the interior bend support. So let me show you this. It is, I think, a bit slow. The depth increases at the bend. The deck is continuous, and it is not like a typical girder where it discontinues at the bend. So if you can see that the depth of the deck increases at the bend, and it decreases towards the abutment. Okay, so it has a maximum depth at the bend. Okay, and the spans, the bridge has two spans of approximately 100 feet each. Okay, so this span is 100 feet and this span is 100 feet. Now we have to model this bridge, or we have to remodel this bridge. So for that we will start from the scratch. Make sure that the units are keep fit. Select the blank document, right? Just close the one window, because one window is enough. Now make sure that in the options, when you go to the request module license, the bridge option is the tick, it is tick marked. Okay, if not, then kindly check it, and it will show you all the features that are required. Now the first step in modeling the bridge is the layout line. Okay, so in creating a bridge object, the first step is to define the layout line. When you go to the bridge, see the layout line. Let me tell you that bridge wizard, if you click it, it will gives you all the details that are required to model a bridge. Okay, so don't worry about this. If you wanna try it yourself, just click it and the menu will appear, and just go through that, and you will be able to model the bridge by yourself. Layout lines, as I told you that these lines are the reference lines used for defining the horizontal and vertical alignment of the bridge and the vehicle lanes. Okay, if you click this add new line, so a window will appear. Layout lines are defined using stations for distance, bearings for horizontal alignments, and grades for vertical alignment, right? Layout lines may be straight, bent, or curved, both horizontally and vertically. The horizontal curves are circular with spirals, and vertical curves are parabolic. So the bridge layout line name given is bridge layout lane 1, right? Coordinates are global. The shift layout line, we don't have to worry about this right now. The units are make sure that it are keep fit, right? And the other details, the coordinates of initial station is 000, the initial and end station data. So initial station is at 0 and end station is, as we know that the span length is 100 and there are two spans, so a total of 200 feet is span length, right? And as soon as you click this horizontal layout data, so it will give you that what kind of layout you want for your bridge. So horizontally I will select straight, my bridge is straight, okay, very good. And vertically it is also straight, so if you want to click it, it's okay, it's already selected. So there is no change in the horizontal and vertical alignment of the bridge, right? So this is your what you said, that bridge layout line data. So you have defined with your bridge layout line, right? And now you have to go to the second step, which is about defining the, see, this is your layout line, right? Now go to the second step, which is defining this deck section, right? Now add new section. See, now different a window will appear where different options are available. For example, the concrete box girders. So these are different box girders where exterior girders vertical, exterior girders sloped, right? Exterior girders clipped, the exterior girders with radius, exterior girders sloped max, right? The H2 PCI standard, the advanced one, these are the concrete box girders, standard girders, right? Other concrete sections can be the T-beam, the flat slab, the precast I girder and precast U girder. And if you guys have read the book of Parker and Puckett, they have solved the 4 examples on all these 4 types, right? And also the steel and concrete sections is there. So for now, I will check the exterior girder, right? And a window will appear where you have to define the values of different properties that were given to you, right? So if you remember that slide which I shown to you before, the data it requires is number of interior girders are 2, keep it as it is. The total width is 36 feet. Okay, how do I know that it is in feet? Because here the units are kept feet. So there is no need to change the data in this window, and just click OK, because this data suits to my required data. I will select OK. Now the important step comes, which is about the bridge object. See, we are done with layout lines, we are done with the deck sections. Now we will jump to the bridge objects. This is the most important thing. Let me take you to the PowerPoint, and we are done with the layout line, we are done with the deck section, right? Now the bridge object, so it says that at least one deck section property and one layout line must be defined before a bridge object can be defined, right? So therefore first we defined the deck section and layout line, and now we are jumping to the bridge object, right? The bridge object definition is the main component of this modeler, and the following can be defined. For example, the bridge spans, the deck sections assigned to each span, parametric deck section variations to each span, the abutments including their skews that are assigned to each bridge, bends including their skews, and the diaphragms, and many more things that can be done in this bridge object, right? So let me take you to the window where you can see that in define bridge object there is an option of add new bridge object. So just click it, and what I was talking about in that slide was this thing. You can see that you can define or modify spans, the abutments, bends, diaphragms, super elevation, pre-stress standards, etc. So bridge object data, it is given the name as bridge object 1. The layout line is 1. If you remember, the only layout line we have defined is BLL1. The units are keep fit. This is global. Now if you see this thing, so it doesn't suit to what we want because there are two abutments that are defined and there is no bend at the middle. So now what we have to do is we have to define a bend at the middle, and it is at a distance of 100 feet, right? So just add it and you can see that a bend has been added. See, the bend is added. Now there are two spans, the span 1 and span 2 and abutment, right? Now for now we are done with it, and we will come back and we will go through all these menus, but we just have to define just one more thing. Okay, what is that? It is the uh, change in depth. If you remember the very beginning of the uh, this video, the depth of the deck was changing at the uh, bend. It was 10 feet at the bend, and it was 5 feet at the ends. So let me click this, right? We were working in this option. Now just for once we are working with the parametric variation, add new variation, and in this window we have to be careful because there are two different spans, and if you go to this, the quick start, right? So it will give you the left span. It is uh, 5 feet at the start, and at the middle it is 10 feet. So this option, the parabolic linear, suits us. Okay, and please make sure that the span id is span 1. Okay, and as soon as you click it, so see the geometry will be like this. Okay, and I want it at 90 feet instead of 70 feet, and the depth, as you know, that it should be 5 feet extra, right? So modify it, and here it should also be 5 feet. So now this will be the configuration of my girders or the deck. It will be 5 feet at the end, and at the middle near 90 feet it will reach the 10 feet of depth, and it will continue as a 10 feet. Okay, now I will, now please keep in mind that this is variation 1, right? Now I have to define the variation 2 for the second span, and as you know that the second span is opposite or mirror to first span. So instead of going for this first parabolic and then linear, I will go with the linear and then parabolic, and I will make sure that the second span is selected here, right? So please make sure that these small details need to be addressed. These are very important things. And as soon as I click OK, so you can see that the configuration is mirror to first one. Okay, so here I just have to make it 5 and modify, and here I have to make it 10 and 5 feet, right? And it is done. See, now we are done with the variation 1 and variation 2. I will click OK, and we will again go back to the same menu. If you remember, which one I told you is this bridge objects, right? Now in this bridge object, the one object I have defined, I will go to the modify show, and now we have to deal with all these menus. For example, the spans. So just click modify show, and it will show you that both the spans have no section variation, which is wrong. So click this button, and the total width remains the same, but the depth will change, right? So for the first span I will select the variation 1, and for the second span I will select the variation 2. Okay, so I will click OK button, and I will go to the abutments because the use discretization points is not important in this video. When you click the abutments and show this value, let me take you to the slide for the abutment values. We are done with this spans. Now for the abutment, see, you have the skewness of 15 degree, so put it as a north, 15 east, right? There is no diaphragm property, none is selected here. The abutment property, the abutment 1 is assigned here, And for the bearing assignment, the bearing 1 and -5 will be selected in our case, and here it will be selected as -5.167, right? Now if you want to see that what these different models we are using, how we can define them. So for example, if you want to know about the diaphragm property, just click this one and add new diaphragm, and it will ask you that since you are working in a concrete bridges, so solid only applies. What you can do is to change the thickness of the diaphragm, right? So in this case 1 feet thickness is given, which is okay. And uh, uh, it was just to show you that you can uh, play with these options. What is the substructure abutment property? For example, the B abutment 1 is defined, and I want to show you that what things you need to know about that. The girder support condition is that connect to girder bottom only. Okay, so your abutment will be connected to the girder bottom only, and it will not be integral. Similarly, for the substructure type, you want to use foundation spring or you want to use continuous beam. I want to use a continuous beam instead of foundation spring. You can go for it as well. There is no problem. The only thing is that you know what you are doing, whether you want to keep it fixed or you want to keep it as a pin. Okay, so similarly, if you want to play with the bearing property, just click plus, and you will see that what bearing property you want to use. For example, the translation in all the three directions are fixed and the rotation are allowed. So you can play in your own way, whatever you want to do. Okay, you can make it free, you can make it fixed, you can make it partial fixed. Okay, so it's up to you, the requirements that you want to meet, and you can play with these things, right? I hope you are getting my point. Now we are done with the abutments. Now, and another important thing is the bends, right? So click on modify show. Again, various parameters need to be defined. For example, the span one, where the bend will be, the bend is at the end of span one, right? And it will be at the start of the span two. The length of this span or the location of the bend is at 100 feet. We know that. Superstructure continuous, yes, our superstructure is continuous and there is no expansion joint or the separation between them. Diaphragm, again it is none, you can select. Okay, again the bearing assignment, you can play with your bearings, the boundary conditions, etc. All the data, it is in front of you, just make sure that it meets your requirements. -6, -8, right? These are the your elevation. The elevation line is in global z direction, please make sure. So dealing with this as well. Now in span cross diaphragms, we are done with abutments, we are done with bends, we are done with spans, we are working with the diaphragms. So I want to assign the diaphragm at a quarter location, for example at 25 feet, at 50 feet, at 75 feet, right? And similarly in the second span, it at 25 feet, at 50 feet, and at 75 feet. Okay, so now we don't need to define the super elevation. The only thing we are left with is pre-stressed tendons. So now I will show you that add new tendon, right? Now here the tendon name is ten1. The tendon load pattern is dead, which is not correct. So click plus button and go to the load pattern and select more, and just go to the pre-stress, give it the name of PT, pre-stress tendon, add new pattern, okay, and click OK. So it will appear, it should appear in your that window, but I think it got hanged or what. Okay, it is taking some time. I wish it is not messed up, because sometimes it is messing up and it wastes my time.